Section 4.2 is a quick section on Rolle's theorem and the mean value theorem, which come from the ideas of maximums and minimums and continuous functions that we looked in the previous section. So again, just like the intermediate value theorem on the previous test, you do need to meet the conditions of these theorems before you can actually apply them. And these theorems do not find the point, they merely show the existence of such point. So let me go through them and you'll understand what I mean more by that. But again, it's very important. The first thing you have to do is meet the conditions of the theorem. The second thing is you draw the conclusions of the theorem that merely states the point must exist. And just the existence of the point is important. We have to use different math, calculus, and algebra to actually find the point. The theorems do not give us the point. Okay. So it says the extreme value theorem in section 4.1 states that a continuous function on a closed interval must have both minimum and maximum values on the interval. So we know the min and max exist, and from the previous section on a closed interval, we know that it either happens at the endpoints or it happens at a critical value. It says both of these values, however, can occur at the endpoints. Rolle's theorem, named after the French mathematician Michel Rolle from 1652 and 1719. By the way, that was a horrible French accent, and I have no idea how to pronounce that crap. But anyways, it gives conditions that guarantee the existence of an extreme value on the interior of a closed interval. So again, the extreme value theorem says it's either at the outsides, the endpoints, or on the inside. And they're talking about absolute maxes and absolute mins with the extreme value theorem. This is Rolle's theorem that just says there has to be a relative max or a relative min on the inside. So what does it say? Rolle's theorem says first condition you have to meet. Your function has to be continuous. Second interval, it has to be on a closed interval. And third, it has to be differentiable. So it has to be continuous on the closed interval. I guess that's really just two conditions if you look at it that way. So the first condition is you have to state that it's continuous on the closed interval. The second condition is you have to state that it's differentiable on the open interval. And the third condition that you have to meet is your endpoints must be the same. F of A must equal F of B. Your endpoints must be the same. Then and only then you can make the conclusion. And the conclusion says you have to have a point where your derivative is equal to 0. Okay? So again, state that it's continuous on the closed interval. State that it's differentiable on the open interval. That's because it's continuous. Determine the endpoints and show that they are of equal value. The y values are the same at the endpoints. Then and only then can you say there has to exist a point where the derivative is equal to 0. Again, this does not find the actual point for you. All this does is give you the existence of a point. Okay. So it says, from Rolle's theorem, you can see that if a function is f is continuous on AB and differentiable, and that's the closed interval, and differentiable on the open interval AB, and if f of A equals A is equal to f of AB. So once again, you have your three conditions. You have to state that it's continuous, you have to state that it's differentiable, and you have to determine that the endpoints are the same. Then there must exist at least one x value between A and B, which the graph of f has a horizontal tangent line. Okay? And essentially what we're saying there is it's going to be a maximum or a minimum, but that's not what the theorem says. The theorem just says the derivative is equal to 0. So it says when the differentiability requirement is dropped from Rolle's theorem, we still have a critical number, but it may not yield a horizontal tangent line. So if you don't have that it's differentiable, you could have something like a cusp or a nice V where we have that critical value, but of course at that point the derivative is not defined.